Uniform plank AB has length 5 meters. Let's give some thickness here. So total length is 5 meters, mass 15 kg. Because this is uniform rod, the weight will act at the center, and the weight is 15 kg. So 15 g will be the weight, g value being 9.81. Plank is held in equilibrium horizontally, two supports A and C. So we'll get two reactions here. So RA and RB, let us call the reactions as RB, RB. Where BC length is 2 meters, find the reaction on the plank at C. Okay, ready?
Yes.
So A bit. So we need to first find this distance. How much is this distance? If you call this as M, MC distance. So MC distance is MB minus BC, right?
Yes.
And MB distance is half of 5. BC distance is 2. So 0.5 meters we will get as MC. Now you have to find RA and RB. So let's go with sigma V. RA and RB are acting upwards, and 15G is acting downwards, equals 0. So RA plus RC equals 15G. This is equation 1. Then take moments, sum of moments about some point. Let's go with A point, moment about A point. 15G is acting, 15G distance is 2.5, and this is going in clockwise direction, so minus. Then RB is going in anti-clockwise, so it should be plus, of course, and the distance is 2.5 plus 0.5, so total is 3, right?
Yes.
So these are the only two forces acting, should be 0. So RB value will be 15G into 2.5 by 3. That's it. So find it. So 3, 5. We get how much? Not this. 5 into 9.81 into 2.5. That's the value we need. That's it. 122.625.
Yes.
Newtons. So RB I told her. So RB is the reaction at C, no? It should have been RC. Okay, we have written RC only. This should be RC. This should be RC. Same way here also we should get RC only. This also is RC. RC value we got it. Now if we substitute RC value back, we will get RA value. But in the question, he has asked value at C only. So this is our A bit solution. Then a person of mass 45 kg stands on the plank at point D as it remains in equilibrium. Reactions of the plank at A and C are now equal. Find the distance AD. Then after some point, there is another person who is standing here. Okay, let's say he's standing at D. Okay, so due to him, the load acting here will be downwards. What is the weight of that person? That is 45 kg. 45 kg means the weight will be 45 times G. G value being this, and he stands at such a position that reactions at A and C are equal. Fine. So for B bit, reaction at A will be equal to reaction at C. This is additional information given. We are supposed to find the distance AD. We are supposed to find the distance AD. AD equal to how much? This is what we need to find. Once again, okay, so let's start with again moment about A. But first, before that, we have to again take sigma V. RA plus RC both are upwards, minus 45G minus 15G. This is the total load, should be 0. So RA plus, now RA is equal to RC now. So in place of RA, we can substitute RC. So we get RC plus RC. On the other side, we will get total how much? 60G now.
Yes.
So RC value, because RC plus RC is 2 times RC, and RC will be 30G, half of 60G, correct?
Yes.
Now we know the value of RC, and now we can go with sigma M. Moment about which point? Moment about A. So 45G, distance is X. This is clockwise. And then we have 15G, and the distance is half of 5 now. This is also clockwise,
Yes.
so minus. And then RC times that distance is 5 minus 2. This one is anti-clockwise, so plus. Total should be 0. So RC value substitute from here. RC value substitute from here. You will get the value of X. So 45 GX equals total. Let's calculate this. So 15 into 9.81 into 2.5, and so this is minus, yeah, this is minus, then plus RC. RC is 30 into 9.81 into 5 minus 2 is 3. So then G value will cancel everywhere, right? So let's, instead of taking it like this, let's keep it. So 45 GX equals, on this side if we take G common, 15 into 5 by 2, this is negative, plus RC. RC is 30G into 3. G has gone out, so we'll go away from here. So G will cancel. We will get the value of X. Okay. So X value minus 15 into 5 by 2 plus 30 into 3 into 3 divided by 45. 1.17 meters. Okay.
Yes.
So that is the distance of the person standing.